I'm Grishma and you're watching my channel G Tutorial. Today is day 4 of our crash course, and in today's class we will be doing more problems from the topic trains. The first class we have discussed the 4 models from the portion trains, and today's class we will deal with the rest of the models. So let us get to our class. This is the 5th model. The first question is: a train of length 250 meter passes a platform of 350 meter length in 50 seconds. What time will the train take to pass a platform of 230 meter length? So we are given that the length of the train as well as the length of the platform and the time taken to cross that platform. Then it is asked, the same train will pass another platform of this length in what time? So if we are using the normal procedure of solving the problem, we can do as follows. We have learned about this distance, speed and time. The speed of the train is given by distance by time, and distance will be length of the train by length of the time taken to cross it. So here we have to consider the platform also, because it is comparable to the length of the train. So length of the train plus length of platform by time taken to cross it gives the speed of the train. So here the speed of the train is 250 plus length of platform is 350 by time taken to cross is 50 seconds. So 12 meter per second is the speed of the train. Now we are asked to find the time taken to cross a platform of length 230 meter. So the time is equal to distance by speed. Distance is length of the train plus length of the second platform by speed of the train. So length of train is 250 meter. Length of second platform is 230 meter by speed of the train is, we have find 12. So 0, 8, 4, 480 by 12. 40 seconds is the answer. If you are following this procedure, it is little bit time consuming. So we can use a shortcut for solving this problem. That is, if we are given length of the train as L and the length of the first platform is X and the time taken to cross is T1, then the same train will cross a platform of length Y in time T2 second, then T2, that is the time taken to cross the second platform, can be easily found using the formula T2 is equal to L plus length of second platform by L plus length of first platform into time taken to cross the first platform. So here it is, length of the train is 250 plus length of second platform is 230 divided by 250 plus length of first platform is 350 into time taken to cross the first platform 50. All should be in same units. So 0, 480 by 12 is 40 seconds. So this is an easy method to solve it. So just by heart this equation. This will help you to solve it within seconds. That is, time taken to cross the second platform T2 is equal to length of the train plus length of the second platform by length of the train plus length of first platform into the time taken to cross the first platform. So just by heart that T2 is equal to L plus Y by L plus X into T1. Okay, now we can move on to the next model, that is the 6th model. This is the next model. From stations A and B, 2 trains start moving towards each other with speeds of 150 km per hour and 130 km per hour respectively. When 2 trains meet each other, it is found that one train covers 20 km more than that of another train. Find the distance between stations A and B. Here it is given that there is 2 stations A and B and 2 trains started moving towards each other. One train is starting from here and the other one is starting from here This train is having speed of 150 km per hour and this one is having the speed of 130 km per hour and they are moving towards each other. After some time, they meet and at the time of meeting, it's found that one train covers 20 km more than the other. That is, the one with higher speed covers 20 km more than the other train. Suppose, let us assume that this train, the second train covers x distance. Then the distance covered by the fastest train will be 20 kilometers more than this. X plus 20. Okay. So the total distance between, we are asked to find the total distance between A and B. So the total distance will be x plus 20, x plus 20. Okay. This is the normal way of doing this problem. So x is the distance from here and x plus 20 is the distance from A to this point. This is the point where both trains meet. So we can say that after some time, after t time, both trains are meeting. Okay. After time t, the trains are meeting. So, the distance is equal to speed into time. No, we have learned from here that distance is equal to speed into time. So, the distance covered by the first train in t time is x plus 20, which is equal to speed of the train. Speed of the train is 150 into time taken to cover us t. This is equation 1. Then the distance x is given by its speed 130 km and it takes t time to cover it. Okay. So let us substitute the value of x from second equation in the first equation. This 2 in 1. So we will get 130t. That is, instead of x we are substituting 130t plus 20 is equal to 150t. We can take this 130 to that side. So 150 minus 130 which is 20t. So 20 is equal to 20t or t is equal to 1. The speed is in kilometer per hour and distance is in kilometer. So the time we obtained is in terms of hour. So 1 hour. 1 hour is the time. So the distance, we are asked to find the distance between. Distance is equal to x plus 20 plus x. Here x is what? 130t. So x is equal to 130 into t is 1. So 130. So 130 plus 20 plus 130 which is 280. 280 kilometer is the distance between stations A and B. This is a normal way of doing this problem. Now I will discuss with you the shortcut for doing this type of problem. Suppose A is the speed of the first train or the faster train and B is the speed of the slower train and the distance D gives the distance covered by the faster train than the slower train at the time of meeting. That is, here it is 20. Here A is 150, B is 130 and D is 20 km. So, the distance between the two stations is given by A plus B by A minus B into D. Here A is 150 plus 130 divided by 150 minus 130 into D is 20. And 20 get cancelled, so 280 kilometers is the distance. So we can do this within 1 or 2 seconds. So this is the easier method for solving this problem. Now we can move on to the next model. This is the next model. Two trains leave Patna for Delhi at 10 am and 10:30 am respectively and travel at 120 km per hour and 150 km per hour respectively. At how many kilometers from Patna will the two trains meet? So, there are two trains. First train is leaving Patna for Delhi at 10 am. The next train is leaving at 10:30 am. And the first train is moving with speed 120 km per hour and the second train is moving with the speed 150 km per hour. Okay. So, the second train is starting at 10:30 am. So first train is moving with a speed of 120 km per hour. That is, in 1 hour it is covering 120 km. So at 10:30 a.m. at what position this train will be? It will be covering half of 120. 120 km per hour. So in 1 hour 120 km. So at 10:30 a.m. that is after half hour, the distance covered is half of this. That is 60 km. So after half hour it will be 60 km from Patna. Okay. And this train is just starting from here. Then let us do the trial and error method. We have to find at the meeting time of both the trains, they will be how much distance from Patna. At this point, that is when the two trains meet, they are at what distance from Patna. This is what we are asked to find. Okay. Let us do the trial and error method for solving this. 60. Now after 1 hour, this train started at 10:30 a.m. At 11:30 a.m. it will be at what distance? It covers, in 1 hour it covers 150 km. So at 11:30 a.m. this train will be 150 km away, and this train will be from here. From at 10:30 it is 60 km plus 120 km. No? In 1 hour it covers 120 km. So 60 plus 120, 180 km from Patna. Then at 12:30 a.m. that is after 1 more hour, 150 plus 150. That is, this train will be 300 km from Patna, and this train will be 180 plus 120, which is again 300. So they are at same distance from this. So the distance from Patna at the meeting point is these two trains will be 300. This is the trial and error method. If you are not able to follow this, we can do another method. That is a normal method. That is, one train is moving with speed 120 km per hour. Other train is moving with 150 km per hour. They are moving in same direction. So what is the relative speed of second train, that is a faster train, with respect to first train? That is difference. So 150 km per hour minus 120 km. That is 30 km per hour is the relative speed of second train with respect to first train. Then the first train has started at 10 a.m. and second train at 10:30 a.m. So at 10:30 a.m. what is the distance covered by the first train? In 1 hour time it covers 120 km, and a half hour time it covers 60 km. So distance covered in half an hour is 60 km. So in what time the train will cover 60 km if the speed is 30? If the this is the distance covered by the first train in that half hour. Then in what time the 60 km is covered by the second train, which is just started now, because first train has already covered 60 km, and in what time this first train will gain that distance? It is time is equal to distance by speed. Here speed is relative speed. So distance is 60 and relative speed is 30. So it's 2 hours time. The second train will gain that 60 hours. And we are asked to find the distance. And so in 2 hours time, both trains will meet. So the distance covered is, distance from Patna is, distance is equal to speed into time. So speed is speed of the second train. We are talking with respect to the second train. So speed of the second train is 150 into time is 2. So 300 kilometer. This is the second method of doing this problem. Now we can do the shortcut or the easiest method to solve this problem. You can follow any of the three methods which you find easy, you can follow that. So here we are given two times. Let the first time be T1, the second time be T2. T1 is the first time, that is 10 am, and T2 is the second time, 10:30 am. Then two speeds are given. First speed is 120 and second speed is 150. So we are asked to find the distance from Patna after which they meet. So it is given by difference of time, T2 minus T1. T2 is larger time now, into product of the speeds divided by difference of the speed. Because B is greater, so we are taking B minus A. Okay, now we can do this. T2 minus T1 is 10:30 minus 10. You have to express in terms of hours because the speed is in kilometer per hour and this is in hour. Okay, and the product of speed is 120 into 150 and the difference is 150 minus 120. This is 30 minutes. You have to convert in terms of hour. 30 minutes is 10:30 minus 10 is 30 minutes. 30 minutes is half an hour. So half into 120 into 150 divided by 30. So 2 into 150 is 300 kilometers. This is the easiest method to solve this problem. Just by heart this. Distance from Patna is T2 minus T1 into A into B by B minus A. Now we can move on to the 8th model. This is the next model. A train overtakes two persons who are walking at the rate of 4 km per hour and 8 km per hour in the same direction and passes them completely in 18 seconds and 20 seconds respectively. Find the length of the train. Here we are asked to find the length of the train if it overtakes two persons who are walking at these two speeds and in time 18 seconds and 20 seconds respectively. So the normal method of doing this is if there is a train, this train overtakes first person who is moving at 4 km per hour speed and the second one who is moving at 8 km per hour in time 18 seconds and 20 seconds. Let us assume that the train is moving at a speed of x meter per second because this time is given in seconds, so I am taking it x meter per second, and it is overtaking a man who is walking at 4 km per hour speed. So the relative speed is difference of, because man and this train is moving in same direction, so we have to consider relative speed. Relative speed will be difference of speed. Always train speed is greater, but here the unit is in meter per second, but the speed of man is in kilometer per hour. We have to convert first into meter per second. So 4 into 5 by 80. So 10 by 9 meter per second. So the relative speed in the first case is x minus 10 by 9. In the second case, 8 km per hour. 8 into 5 by 80. 2 4s are, 2 9s are, 4 5s are, 20 by 9. X minus 20 by 9 meter per second. These are the relative speed in both cases. We have to find length of the train. Length of the train is, length is distance. Distance is equal to speed into time. Speed into time. Length is same because same train is crossing both persons. So we can equate the speed into time formula in both cases. Speed, in first case, speed is relative speed is this, x minus 10 by 9 into time taken crosses 18 seconds. And in the second case, the speed is x minus 20 by 9 and the time is 20. On solving this, we will get the value of x. X is the speed, and in substituting in any of the formulas, speed into time, we will get the value of length. This is the normal procedure for solving this type of problem. Now we can move on to the shortcut. Shortcut is length of train is equal to difference of speeds of persons into time for crossing the first person, time to cross the second person by difference of time. This is the easiest method to solve this. Difference of speed is 8 minus 4. First time is 18 seconds. Second time is 20 seconds. Do not forget to multiply by 5 by 18 because time is in seconds but the speed is in kilometer per hour. This is where everybody makes mistake. T2 minus T1 is 20 minus 18. So 18 and 18 get cancelled. 20 minus 18 is 2. 2 and 20 get cancelled. 10. So 8 minus 4 is 4. 4 into 5 into 10. 4 5 is 20. 20 to 10 is 200. 200 meter is the length of the train. Because everybody is expressed in second, meter per second, etc. Don't forget to multiply by 5 by 18 because speed is in kilometer per hour but time is in second. This is the easiest method to solve this type of problem. Now we can move on to the model 9. We can discuss the rest of the models in the next class. If you are having any doubts, we can comment below. Thank you.